Hi there. We are looking at some practice problems with the fundamental theorem but we're kind of doing it under the guise of particle motion. So we have some application going on there as well. If this is the first time you are seeing my face, hi, I'm Dr. Marissa May. I am on a mission to help students feel confident in their math classroom. And so today we're looking at some calculus problems. This is primarily AP calculus. This could be AB or BC, although I'm kind of directing it towards AB. But of course, BCers, you need to know this as well too. And we're diving in so that we can kind of see some practice and make some progress. So let's take a look. If you've seen any of my videos before, you know I preach that most of the time the graph you're going to be looking at is that velocity graph. And in fact, we are correct in this problem. And we're also told that the initial position of the particle at time t equals 0 is 12. That's important. And we've got this nice line segment, semicircle, line segment. So on what interval is the particle moving to the left, and on what interval is it moving to the right? Well, remember, if I'm looking at the velocity, then I'm looking at the y values to determine. So we are moving to the left on the interval that it's negative, and that's from about 8.5 to 10. And that's because the velocity is negative. Now, we then would be moving right on the interval from 0 to 8.5 because the velocity is positive. All right. Now, number two, what is the total distance the particle has traveled on the interval from 0 to 7? Leave your answer in terms of pi. Be sure to include units of information. So, units of measure, not information. Remember, total distance is the integral of the absolute value of the velocity. Lucky for us, from 0 to 7, we do not have any negative areas that we're going to have to account for. We are going to have to break this up, though. Friends, I'm thinking I'm going to do a trapezoid there. This next section, though, I'm going to have to do a rectangle and subtract out a semicircle. So let me show you how I would do that. So I'm going to do my trapezoid first. That's 1/2 times the height, which is 3, and then add the bases, 2 and 4. Then I'm going to add the rectangle. So that rectangle goes from 3 to 7. It has a width of 4, and it has a height of 4. But then I'm going to subtract the semicircle out. So it's half pi, and the radius of that semicircle is 2, and so I square that. Okay, so let's simplify. I've got 6 times 3 is 18, times a half is 9, plus 16 is 25, minus 4 times a half is 2 pi. And so my units here would be meters for total distance. Okay. My next problem asked me for net distance. So remember, net distance is where we're actually we want to keep the negatives on the negative areas. So let's go from 5 to 10. So friends, on this one, I'm going to have to do the rectangle again. Do the rectangle minus a quarter circle. Then I've got these two triangles that actually we're going to cancel. They look like they're going to cancel each other out, and they are. So I'm just going with this rectangle minus the quarter circle there. Okay, so the rectangle is a 2 by 4, and then I'm going to subtract out a quarter circle with a radius of 2. Okay, so that gives me 8 minus pi, and we want to round to the nearest 1,000. So let's get our calculator, and I get 4.858, and again, that's in meters. Okay, next question, what is the acceleration? So if I'm looking at the velocity, the acceleration is the slope. So I want the acceleration at 2, that's right here. It's on a line segment that has a slope of 1, 2, run 1, 2, 3. So my acceleration at 2 equals 2/3, and that's in meters per second squared. And the last question for this part would be, what is the position of the particle at time t equals 5? So we're going to use the area. We were told the position at 0, so I'm going to use the area from 0 to 5 of the velocity. That gives me the position. And so I'm going to do the area on the graph from 0 to 5. I'm going to use that trapezoid again, and then it looks like I have to do a rectangle minus a quarter circle. So that trapezoid was 1/2 times 3 times 2 plus 4. Then let's do the rectangle, which would be from 2 to 5. So it has a width of 2 and a height of 4. And then subtract out the quarter circle. So that's 1/4 pi 2 squared. Okay, that should equal, now plug in my bounds, p of 5 minus p of 0. So now I've got 6 times 3 is 18, times a half is 9, plus 8 is 17, minus pi equals p of 5 minus, and we were told position at 0 was 12. So add our 12 to both sides. P of 5 is 29 minus pi meters. Remember, this is just a backdoor with the fundamental theorem to be able to find values for the function, or the position in this case. Okay, let's do another one here. Now, notice on this one, again, we're given the particle's velocity on the interval from 0 to 4, and we're asked for, when does the object move to the right? We're looking for positive y values because we're looking at the velocity. So it goes to the right from, I need a bracket, from 0 to 1. Then it goes from 1 to 2. You may be asking yourself, why would I break that apart? Well, I actually have to, because that's where the velocity equals 0. The object paused for a moment and then it kept moving. And actually, I actually can keep going here to 3, from 1 to 3. And it's because the velocity is positive. Okay, so when is the object moving to the left? That's from 3 to 4, 3 to 4, and that's because velocity is negative. Oh, look at this one. For what values is the speed of the particle increasing? So we're looking for velocity and acceleration to have the same sign. So I need the velocity, I need the y value, and the slope to be positive. Velocity is positive and slope is positive in this section. So from 1 to 2, then look for where the velocity is negative, the y value is negative, and the slope is negative. That's in this section. And that's because velocity and acceleration have the same sign. Okay, look at number 9 then. When is the speed of the particle decreasing? So this is where you're looking for them to have opposite signs. Let's deal with the velocity being positive, the acceleration being negative. So I need positive y value, negative slope. Positive y value, negative slope happens in this section. And then I need negative y value, positive slope. Negative y value, positive slope. Well, the only place I have a negative y value is down here, and I don't have a positive slope. So this is going to have to be it, because velocity and acceleration have different signs. Okay, number 10 says, what is the net distance that the particle travels on the interval? So net distance, we want to pay attention to positive and negative areas on this one. So we're doing the integral from 0 to 4 of the velocity. Okay, so it looks like I'm going to do a rectangle minus a semicircle. Then I've got two triangles that are going to cancel each other out. So it looks like I'm doing this rectangle minus the semicircle. So the rectangle is a 2 by 1, and the semicircle is a 1/2 pi, and the radius looks to be 1. So it looks like I'm getting 2 minus a half pi. Okay, now if we do the total distance, so I'm going to do the total distance, which means any negative areas, I'm actually going to make them positive. So I know I have the rectangle minus the semicircle, but then I have these two triangles I need to account for. So I'm going to pick up my answer from number 10, because that's the rectangle minus the semicircle. Then I'm going to do this triangle and I'll double it. That'll make it easy. Okay, so triangle is 1/2. The base is 1. The height is 1. So it looks like I have 2 minus half a pi plus 1, or 3 minus half a pi. So remember, those total distance is where we take those negative areas and we actually make them positive. Makes it a little bit simpler. Makes the distinction between the total distance and the net distance. All right, one more problem to look at here. One more stem, I should say, several problems. A car travels on a straight track during the time interval 0 to 60. You're given values for the velocity and the acceleration in the chart. So using appropriate units, explain the meaning of this integral and then approximate the meaning using midpoint approximation. Okay, so the meaning, when we have absolute values on the velocity, this is the total distance. Let's see, is the total distance traveled from t equals 0 to t equals 60. Okay, now let's do a midpoint approximation for those. So in order to do a midpoint, I'm going to have to break them up in this way. We'll do 3 intervals. Each of the intervals looks to have a different width, and that's okay. We can do that. So I've got a width, first of all, of 25 and a height coming from the midpoint. But remember, we're doing absolute value, so I'm going to make that a positive 30. Then this one has a width of 10. Go to the midpoint. I'm going to make it positive 14. And this one has a width of 25, and I'm going to use 0 as the height. 30 times 25 would be 750, plus 140 plus 0 gives me 890 feet. Okay, number 13 asks me explain the meaning of this integral. The integral of the acceleration. So let's see, this is the change in velocity on the interval 15 to 50. Okay, so if we do the integral of the acceleration, the antiderivative would be the velocity, and now we plug in our bounds. The velocity at 50 minus the velocity at 15. Now you can go to the chart. The velocity at 50 is 0, and the velocity at 15 is negative 30. So that gives me 30 feet per second because it's velocity. Okay. Now look at number 14. Is there a value such that a prime of t equals 0? If so, on what interval does such a value exist? Is justify your reasoning. Remember, only 2 theorems that guarantee us a value for the derivative. Rolle's theorem, mean value theorem. Rolle's theorem guarantees us that it equals 0. But I'm looking for a prime, so I'm going to look in this row. Is there a value such that a prime of 0 equals? Yes. Rolle's theorem guarantees that a prime of t equals 0 on the interval. Let's just do this one, 0 to 30. Because a of t is continuous and differentiable. And what's the last criteria for Rolle's theorem? Those endpoints have to equal each other. Yeah. Okay, now 15. Use appropriate units. Approximate the value of v prime of 31. What does this say about the motion of the particle at that time? Okay, so v prime of 31. That means we're going to do, if we have to approximate it, we're going to do the slope the algebra way around 31. So maybe let's do 30 to 35. Okay, so I'm going to do v of 35 minus v of 30 over 35 minus 30. Okay, now plug in your values. V of 35 is negative 10. V of 30 is negative 14. And you get 5. So you get 4/5. And the units here, because v prime is acceleration, are feet per second squared. So if this is positive, what does that mean about the motion of the particle? The object is accelerating. At t equals 31, because v prime of 31 is positive. All right, last one here. Using the appropriate units, find the value and explain the meaning of 1 over 35 integral from 25 to 60 of a of t. Well, first of all, the meaning of it here is we're doing the area and we're dividing by the length of the interval. See, 25 to 60 is 35. This is average value. Remember average value formula, 1 over b minus a, integral from a to b of some function. Okay, so this is the average value. This is the average value of the acceleration on the interval from 25 to 60. Okay, so now let's calculate. We've got this 1 over 35 in front, but we're going to take the antiderivative. So the antiderivative of the acceleration is the velocity. And then we're going to plug in our bounds. So that gives me v of 60 minus v of 25. Now we can go to our chart. V of 60 was 10. Don't forget, I still have the 1 over 35 in front. V of 60 is 10 minus V of 25 is negative 20. So I've got 30 over 35. Or I've got 5, nope, I've got 6/7. And this is velocity, this is acceleration, right? So this is feet per second squared. All right. Now, I do recommend for this type of problem some AP free response, and I'm going to link them below. I'll link the solutions to them below. There's a really good one on the 2001 AB exam problem number 3, and then the 2002 Form B problem number 3. Great problems here. I will link the solutions to those below. That way you have them. And don't forget to hit that like and subscribe button. That way you get a notification every time a new video is posted. Bye for now.